we are in 3.6, which is polynomials and rational inequalities. Here are our objectives: solve polynomial inequalities and solve rational inequalities. So let's begin with the definition of a polynomial inequality. A polynomial inequality is any inequality that can be put into one of the forms f of x is less than 0, greater than 0, less than or equal to 0, or greater than or equal to 0, where f is a polynomial function. So let's talk about steps for solving a polynomial inequality, because unlike our polynomial equations, our solutions could be intervals. So the first thing you want to do is express the inequality in the form f of x less than 0 or greater than 0. Now remember, you also have an option that it could be less than or equal to 0 or greater than or equal to 0. And then you want to solve the equation f of x equals 0. So the first thing you want to do is make sure that you have 0 on the right side of the equation. And then the second thing you're going to do is basically ignore the inequalities and solve the equation f of x equals 0. Whatever these answers or solutions come out to be, these are your boundary points. And then of course you're going to draw a number line and put your boundary points on that number line. Therefore you are actually dividing the number line into intervals. And then step 4, the most important step, which I feel a lot of students seem to forget, you must pick a test value from each interval and plug it in to f. Remember, that's what evaluate means. You want to plug it in, okay? You need to pick a test value from each interval and plug it in. If the value of f is positive, then f of x is greater than 0 for all x's in that interval. So whatever x or test value you pick, if you plugged it into f and it came out to be positive, then you're saying that f of x is greater than 0 for that interval. And if you take your test value and plug it into f and it comes out to be negative, then you're saying f of x is less than 0 for that interval. And then, of course, last step is to write the solution set, selecting the interval or intervals. Let me say that again. Write the solution set, selecting the interval or intervals that satisfy the given inequality. Having a hard time talking this morning. I apologize. Okay, so 5 steps to solving polynomial inequalities. Step 4 is the most important and the one easily forgotten about. So let's practice one. Let's go in our books to page 420, and we're going to start by looking at number 17. And it says, solve each polynomial inequality and graph the solution set on a real number line. Express each solution set in interval notation. So we have 5x less than or equal to 2 minus 3x squared. Okay, so the first thing we need to do is we need to have 0 on the right side. So we're going to move the 2 and the minus 3x squared to the left side. Move the 2 by subtracting 2 on both sides. So now you have 5x minus 2 less than or equal to negative 3x squared. And then we're going to add 3x squared on both sides. And we get 3x squared plus 5x minus 2 is less than or equal to 0. So this is our polynomial inequality in the right form. That's step 1. Which means now we're going to solve the equation 3x squared plus 5x minus 2 equals 0. So the second thing we need to do is solve 3x squared plus 5x minus 2 equals 0. Now, if you are decent with factoring and you are comfortable with factoring, I believe you can factor this one. If not, you can always resort back to the quadratic equation. So for this one, I am going to do the quadratic equation just in case some of us aren't comfortable with factoring. So the a is equal to 3, the b is 5, and the c is negative 2. So then we get negative b plus or minus the square root of b squared minus 4ac all over 2a. And this will give us our x's. So let me move up here now. So this is step 2. Continue. So we're going to have x is equal to negative 5 plus or minus the square root of 5 squared minus 4 times 3 times negative 2 all over 2 times 3. Use our handy dandy calculators and let's see what we come out with. Negative 5 plus the square root of 5 squared minus 4 times 3 times negative 2 all divided by 2 times 3. So I get 1x to be 1/3. So I got an x equal to 1/3. And let's try it again for the other. So now subtract, and we get a negative 2. So remember, the second step is to solve the equation. So turn your inequality to an equal sign, and now you can just solve it like we normally do. And I use the quadratic, and I get x is 1/3 and negative 2. Okay, which means now these are my boundary points. So the third thing we need to do is draw a number line and place these boundary points on the number line and, put them in their respected area. Obviously, negative 2 will come before 1/3. Now, because these are boundary points, we are creating intervals. So let's talk about how we're going to make our intervals. Go back to your inequality. You see it says less than or equal to. And that equal to is what we're going to be focusing on right now. Because it has that equal sign, we know we want to use brackets, right? Brackets. So we're going to put a bracket on negative 2 facing the left, as well as a bracket facing the right. And we're going to do the same thing on 1/3, facing the left and facing the right. If this would have just been a less than with no equal, so if it would have just said less than 0, we would have put a parentheses facing the left and a parentheses facing the right on each of these. Okay, so what I'm going to do is I'm going to go ahead and write my intervals above each interval. So the first one is negative infinity. So I'm all the way out here at negative infinity and I'm traveling along and I hit negative 2 with a bracket. That's this interval. The interval in the middle is negative 2 to 1/3. And the last one is 1/3 out to infinity. It's helpful to write the intervals above your number line. Okay, now step 4, the most important step, is testing a number in each interval. So let's pick a number in this interval, and what we're going to do is plug it into f. So I'm going to pick the number negative 5. Negative 5 is in this interval. In the middle interval, I'm obviously going to pick 0. And out here, I'm going to pick, 1. So your test values, now you're going to plug into your function. So f of x is equal to 3x squared plus 5x minus 2. 3x squared plus 5x minus 2. And one at a time, we're going to plug it into f. So f of negative 5 Everywhere we see an X, we're going to put a -2, and then we're going to get our handy-dandy calculators out. And let's see what we come up with. Well, obviously I was about to make a mistake, wasn't I? I should be plugging -5 in. I'm not sure where that 2 came from. That should be a -5. Let me fix that. And let me go back to my calculator now. And I get 48. Hopefully you got 48 too. Now 48 is greater than 0, which means in this interval, it's positive. So in this interval, it's positive. So let's test the next one, f of 0. Well, I know that's just going to be -2, which is less than 0. So in the middle interval, f of x is negative, or less than 0. And then let's test the last the last test value. And let's see what we get. Oh, my pen. And we get 6, which is greater than 0. All right, so the last step is to actually write out our answer, right? So this is step 5. This is writing out our answer. Let's go back to this. This was less than or equal to 0, which means we're looking for all of the values that came out to be negative, because it says less than 0. The only one that came out to be negative was the second test point, which was 0, which is found in the middle interval. Therefore, our solution is just going to be -2, a third. And make sure you're using brackets because it says less than or equal to. Now let's look at why the other two intervals are not part of our solution. It says less than or equal to 0. When we plugged in -5 from the first interval, we got that f of x was greater than 0. Therefore, he's not part of our solution. And the same when we plugged in 1, we got greater than 0. So our solution is -2 to 1/3 with brackets. All right, let's keep going. So now we just finished talking about polynomial inequalities. Now let's look at the rational inequality. So a rational inequality is any inequality that can be put in the form f of x less than 0, greater than 0, less than or equal to 0, and greater than or equal to 0, where f this time is a rational function. So let's talk about the steps. Some of the steps are the same and some are different. Step 1 is different. It says express the inequality so that one side is 0 and the other side is a single quotient. Remember, rational functions was in the form of p of x divided by q of x, where p and q were both polynomials. So when you have 0, once you get 0 on the right side, you want to make sure on the left side that you have a single quotient. That would be your rational function. Step 2 is to set the numerator and the denominator equal to 0. You have a top and a bottom. Set them both equal to 0. And then, of course, you're going to locate the boundary points on the number line and divide the number line into intervals. And then step 4, you're going to choose a test value just like you did before and test each interval. This is the same step 4 as before. And then step 5, write out your solution set. So the main thing that's different between the polynomial inequality and the rational inequality is step 1 and step 2. So let's look at an example problem. We're still in our books on page 420. We're going to look at number 57. And it has x plus 4 divided by 2x minus 1 is less than or equal to 3. Okay, well, step 1 said you need to have a 0 on one side and a single quotient on the other. So the first thing we're going to do is subtract 3 on both sides. And we'll get x plus 4 divided by 2x minus 1 minus 3 less than or equal to 0. Okay, so we have the 0 on the right side, but do we have a single quotient on the left side? The answer should be no, which means we need to make it a single quotient. So I basically have a fraction minus a number. In order to do that, we need to have the same denominator. So our least common denominator is going to be 2x minus 1. Let me make some room. So our least common denominator is 2x minus 1, which means how can we get a 2x minus 1 on the bottom here? Well, we can just write it down there, can't we? Which means on the top, we have to multiply it by 2x minus 1. Write it down on the bottom, multiply it on the top. Now they have the same denominators, right? And that's totally valid because all I did was multiply by 1. You see 2x minus 1 over 2x minus 1. They cancel out, and I didn't change a thing. So now we have x plus 4 minus 3 times 2x minus 1 all over 2x minus 1 less than or equal to 0. And before we go to step 2, let's go ahead and clean this up. So distribute that negative 3, and be careful because it is negative. And you should end up with negative 5x plus 7 over 2x minus 1. Alright, hold on for a second. Let me verify myself. Negative 6x plus 1, negative 5x, positive 3 plus 4, 7. Good. Less than or equal to 0. So now we move on to step 2, which was to set the numerator and the denominator equal to 0. So set the numerator and the denominator equal to 0. Numerator, negative 5x plus 7 less than or equal to 0. And the denominator, 2x minus 1 less than or equal to 0. Oh, I'm sorry. My fault. Equal to 0. Remember, at this point, we ignore our inequality signs and we turn it into an equation because we can solve those. So go ahead and solve each equation. So this one will come out to be x is equal to 7 over 5. And this one will come out to be x is equal to 1/2. And then we draw a number line. And we place these values on the number line. So 1/2 will come before 7/5. Now we need to talk about whether it's a parentheses or a bracket. So let's start with the denominator, that 2x minus 1, which came out to be 1/2, right? Can you divide by 0? The answer should be no, which means you'll never put a bracket on this x. Whenever you set your denominator equal to 0 and you get a boundary point, it will always be a parentheses facing to the left and a parentheses facing to the right because you cannot divide by 0. However, for the numerator, in order to determine what you use for the numerator, you actually look at the inequality sign. So this one says less than or equal to. Because of that equal sign, we must use brackets. Bracket facing to the left and a bracket facing to the right. Okay, so let me repeat that. When you set your numerator equal to 0, to determine if it is a parentheses or bracket, you look at the inequality sign. This one says less than or equal to. Because it has equality, we use brackets. One facing to the left, one facing to the right. When you set your denominator equal to 0, it will always be a parentheses facing to the left as well as facing to the right because you cannot divide by 0. Therefore, you're saying it can be all values close to 1/2, but it'll never be 1/2. Because if you plug 1/2 in for x, you'll get a 0 on the bottom, and that's a no-no in the math world. All right, so that was step 3. So what we're going to do is write the intervals above them, like we did before. Negative infinity to 1/2, parentheses, parentheses 1/2 to 7/5, bracket. bracket 7/5 to infinity. Now, this is not our answer. We must use our test values, right? So step 4, the most important step, the one easily forgotten, because we would like to stop here and say this is our entire answer. But step 4 says you must pick test values and plug them into your function. So I'm going to pick the value 0 over here. How about 1 here? And just to be safe, we're going to say 2 here. So we're going to plug this in f of x, and f of x this time is this piece right here. Now, how do you determine which piece is f of x, right? You want the final, I guess I can say final edit, or the final form, whichever work. I have a hard time with my words. Let's say it this way. If you have a 0 on the right side and a single quotient on the left side, that quotient is your f of x. That was better. So f of x is negative 5 plus 7, negative 5x plus 7 over 2x minus 1. And one at a time, we're going to plug these test values in. So when you plug 0 in, you should get negative 7, which is less than 0. And when you plug 1 in, you should get 2, which is greater than 0. Now, of course, let me verify that with my handy-dandy calculator. Negative 5 plus 7 over 2 minus 1 is 2, which is greater than 0. And then when you plug the 2 in, let's see what we get. Negative 5 times 2 plus 7, divide by 2 times 2 minus 1, and we get negative 1, which is less than 0. And then the last step, step 5, is writing out our answer, right? So let us go back to our inequality. It said less than or equal to 0. So you want all intervals that gave you a negative when you plugged in the test values. This one gave us a negative, and this one. So where did 0 come from? It came from this interval. So that's part of our solution. Negative infinity to 1/2. And make sure you're using parentheses, right? And then we also got a negative when we plugged in 2, and that came from this interval. Now, because we have 2 intervals, let's make sure we're using our U for union. And we got bracket 7/5 to infinity. Okay, so this will conclude our video for 3.6. If you have any questions, please email me.